Section 4.1, example 4, we have page 244, says, suppose you are given a set of polynomial function outputs. You know that their inputs are an ordered set of x values in which the consecutive x values differ by a constant. By analyzing the differences of consecutive y values, it is possible to determine the least degree polynomial function that could generate the data. If the first differences are constant, the function is linear. If the second differences, but not the first, are constant, the function is quadratic. If the third differences, but not the second, are constant, the function is cubic, and so on. So example 4 says, what is the degree of the polynomial function that generates the data shown at the right? The first thing you need to verify is that all of the x values are increasing by the same amount each time. So to get from -3 to -2, I added 1, -2 to -1, I added 1, -1 to 0, I added 1, 0 to 1, I added 1, 1 to 2, I added 1, 2 to 3, I added 1, and so on. If at some point it skips, you have to account for that in your y values. This one's already set up so that they all go up by 1, so we're only going to look at the y values. So I have expanded the y values, and we want to look at the difference between two terms that are consecutive. So from -1 to -7, we subtract 6. From -7 to -3, we add 4. From -3 to 5, we add 8. From 11 to 9, we subtract 2. And from 9 to -7, we subtract 16. Now, when we say the differences are constant, that means all of these numbers would match, which they don't. So the first differences are not constant. If the first differences are not constant, we move on to the second differences. So now I want to know how to get from -6 to 4. So for that, we add 10. From 4 to 8, we add 4. From 8 to 6, we subtract 2. From 6 to -2, we subtract 8. And from -12 to -16, we subtract 14. Again, these do not all match, so the second differences are not constant either. If both the first and second differences are not constant, we need to continue, so we're going to check the third differences. To get from 10 to 4, we subtract 6. From 4 to -2, we also subtract 6. From -2 to -8, we subtract 6, so this is looking good, but you have to make sure you check everything in the table. From -8 to -14, we also subtract 6. So here, the third differences are constant. And since the third differences are constant, we say the degree of the polynomial function is 3, because it took 3 sets of differences to get a constant difference. All of this work is on the next few slides of the computer. And the final answer. So now I would like you to determine the degree of the polynomial function with the given data. Notice if you check the x values, they are all increasing by 1 again, so you can focus on just the y's.